Hello all, this is Sahiti on behalf of Edureka and I welcome you to this session on DBMS interview questions. So in this session guys, we'll focus on the different questions that could be asked in your database administrator interviews. So without any further ado, let's get started with today's session. So the topics for today's session are as you can see on my screen. I'll start this session by talking about the top generic DBMS interview questions and then I'll discuss few SQL interview questions and SQL query interview questions. So I hope the flow is clear to you. Alright, now before I move on with the session, I would like to request all of you to subscribe to our Edureka YouTube channel to get daily notified on the top trending technologies and build your careers. So on that note, let's get started with today's session. Now, as all of us know that there's no place where data does not exist. So in today's market where around 2.5 quintillion bytes of data gets generated every day, it's very important for all of us to analyze the data and generate the required results. But before that, we have to handle databases using the database management systems. Well, knowing database management systems definitely opens the doors for database administrator, and I believe you know this fact. So in this session, we'll talk about the generic DBMS interview questions initially, and then I'll talk about SQL, which is the base to database management systems, right? So let's get started with the first section of the session, that is generic DBMS interview questions. So the first question that we have is, what are the differences between DBMS and RDBMS? Now, obviously, all of us know that what is DBMS, right? It's an acronym for Database Management System. So if you have to compare DBMS and RDBMS, then I would say DBMS provides an organized way of managing, retrieving, and storing from a collection of logically related information. But when it comes to RDBMS provides the same way as that of DBMS, but it provides with relational integrity. So database management system in general is very common. It's just a system which provides an organized way of managing and retrieving information. Now what happens in RDBMS is that the complete data present in the database is related to each other and is mostly stored in the form of tables. Now I would also say that RDBMS is a type of DBMS, or you can say it's a kind of DBMS. So it basically you have a DBMS and then you have various kinds of it, and RDBMS is one such kind of that. So I hope this part is clear. Now let's move forward with the next question, that is explain the terms database and DBMS and also mention the different types of DBMS. Now I'm sure everybody understands what database is, right? So in layman terms, if you have to explain database, then I would say that you can consider database as a big container where all your data is present in a logical format, right? So you can retrieve data from this particular database and then generate the required results. Now coming to DBMS, if I have to define DBMS for you, then it's a software application which interacts with the databases, applications, and users to capture and analyze the required data. So the data stored in the database can be retrieved, deleted, and modified based on the client's requirement using the database management systems. So you have a client and then you have a DBMS, that is basically a software application through which you can access the database. Now the different types of database management systems are relational database management system, hierarchical database management systems, network database management systems, and object-oriented database management systems. Talking about relational database management systems, this type of database management system uses a structure which allows the users to access data in relation to another piece of data in the database. So in this type of database management system, data is mostly stored in the form of tables. Coming to hierarchical database management system, as the name suggests, this type of database management system has a structure similar to that of a tree, wherein the nodes represent the records and the branches of the tree represent the fields. In the hierarchical one, you have a tree structure, and the relational one, all the tables are related to each other. Coming to the network database management system, this type of database management system supports many-to-many relations wherein multiple member records can be linked. And coming to the final type of DBMS, that is object-oriented, well, this uses small individual softwares called as objects to store pieces of data and the instructions for the actions to be done with that particular data, right? So if you have to understand all these terms in layman language, guys, then RDBMS is basically where all the data is related to each other. Well, coming to hierarchical is in the form of a tree. Network comes where you have many-to-many relations where multiple member records can be linked together. And object-oriented, you have objects which have specific set of data and the instructions for actions to be done with that particular data. So I hope this part is clear. Now let's move forward with the next question, that is, what are the advantages of database management systems? And I would say this is one of the most popular questions that is asked in the interviews, that you have to know what is the advantage before you start using anything, right? So the advantages of database management systems are data independence, sharing of data, integrity constraints, redundancy control, and provides backup and recovery facilities. Talking about data independence, this allows to change the structure of data without affecting the structure of any of the running application programs. Coming to sharing of data, multiple users can use the data from the same database simultaneously. Coming to integrity constraints, these constraints allow the data to be stored in database in a refined manner. Coming to the next one, that is redundancy control. It supports a mechanism to control the redundancy of data by integrating all the data into a single database. And finally, coming to providing backup and recovery facilities. These provide a feature of backup and recovery to automatically create the data backup and restore the data as and when required, right? So that was about the advantages of DBMS, guys. Let's move forward with the next question, that is mention the different languages present in DBMS. The different languages present in DBMS are mainly DDL, DML, DCL, and DCL. Talking about DDL, so DDL is basically data definition language, which consists of commands which are basically used to define the database, right? So whenever you want to define the database, that is basically do the groundwork or the foundation of your database, you have to start using the DDL commands. Coming to DML, so DML are basically data manipulation commands, which consists of all those commands which are used to manipulate the data present in the database. So once your foundation is built, you have to manipulate data, right? So that's where DML commands come into the picture. Coming to DCL, well, DCL consists of commands which deal with the user permissions and controls of the database system. And finally, coming to TCL, well, TCL is transaction control language, which consists of commands which deal with the transaction of the database. Well, DCL is data control language, right? So whenever you want to control the user permissions or grant a user a specific permission, that's where DCL comes into the picture. And whenever you want to deal with the transaction of the database, that is when TCL comes into the picture. So guys, these are the main different languages present in DBMS, that is DDL, DML, DCL, and TCL. Now let's move forward with the next question, that is, what do you understand by query optimization? Well, the answer to this particular question is really simple. Query optimization is the phase which identifies a plan for evaluating query that has the least estimated cost, right? So this phase comes into the picture when there are a lot of algorithms and methods to execute the same task. So if you have to explain query optimization for anybody, then it's really simple that, it's a phase which identifies a plan for evaluating query and make sure that, it has the least estimated cost, right? Now, the advantages of query optimization are basically the output is provided faster, a larger number of queries can be executed in less time, and it reduces time and space complexity. Now let's move forward with the next question, that is, do we consider null values the same as that of the blank space or zero? Well, I would say a null value is not at all same as that of zero or blank space. That is because, null value represents a value which is unavailable, unknown, unassigned, and not applicable, whereas zero is a number and a blank space is a character. So all these three terms are completely different, guys. Zero is a number, blank space is a character, and null represents a value which is unavailable, unknown, unassigned, or not applicable, right? What do you understand by aggregation and atomicity? Coming to aggregation first. Aggregation is a feature of the entity relationship model which allows a relationship set to participate in another relationship set. Coming to atomicity, well, this property states that a database modification must either follow all the rules or nothing at all, right? So even if one part of the transaction fails, then the entire transaction fails. So guys, these are two completely different concepts. So if you want to know more about both of them, you can refer to my session on MySQL tutorial where I've explained entity relationship diagram in depth. And you can understand what is aggregation and what is atomicity. Now let's move forward with the next question, that is, what are the different levels of abstraction in database management system? Well, there are mainly three different levels of data abstraction, that is physical level, logical level, and view level. Coming to physical level first, well, it is the lowest level of abstraction and describes how the data is stored. Coming to logical level, the logical level is the next level of abstraction after the physical level. Right, so this layer basically determines what data is stored in the database and what is the relationship between the data points. Coming to view level, well, view level is the highest level of abstraction and it describes only a part of the entire database. There are mainly three different levels of data abstraction, that is physical level, logical level, and view level. Now let's move forward with the next question, that is, what is an entity relationship model? Well, if I have to define entity relationship model for you, then it's a diagrammatic approach to database design where you represent real-world objects as entities and mention relationships between them, right? So this approach basically helps the team of database administrators to understand the schema very easily. So that was about ER model, guys. So now that you know what is ER model, let's understand the next question. That is, what do you understand by the terms entity, entity types, and entity set in database management system? Coming to entity first. Well, entity is a real world object having attributes which are nothing but the characteristics of that particular object, right? For example, an employee can be entity, and this particular entity can have attributes like employee ID, employee name, employee phone number, and so on. Coming to entity type. Entity type is nothing but a collection of entities having the same attributes, right? So generally an entity type refers to one or more related tables in a particular database. So you can just understand entity type as a characteristic which uniquely identifies the entity. For example, an employee can have attributes such as employee ID, employee name, and department, right? Now this particular entity can be of entity type, as you know, a lot of entities can have the similar attributes. Coming to entity set. Well, entity set is a collection of all the entities of a particular entity type in a database. For example, a set of employees, a set of companies, or a set of people can come under an entity set. So guys, this is what entity, entity type, and entity set means. Moving on to the next question, that is, what are relationships, and mention the different types of relationships in database management system. Well, I would say a relationship in database management system is a scenario where two entities are related to each other. In such a scenario, that the table consisting of the foreign key references to that of a primary key of the other table, right? So if you have two tables, table A and table B, then the foreign key of table A will reference to that of the primary key of table B. Now, the different types of relationships present in database management system are one-to-one relationship, one-to-many relationship, many-to-one relationship, and self-referencing relationship. Coming to one-to-one relationship, well, this is used when a single row in table A is related to single row in table B. Coming to one-to-many relationship, this is used when a single row in table A is related to many rows in table B. Coming to many-to-many relationship, this is used when many rows in table A can be related to many other rows in table B. And finally, coming to self-referencing relationship, this is used when a record in table A is related to the same table itself, right? So that is basically the entity is related to itself. So guys, these are the four types of relationships. Now let's move forward with the next question, that is, what is concurrency control? Well, concurrency control is a process of managing simultaneous operations in a database so that the database integrity is not compromised. Well, there are mainly two approaches involved in the concurrency control, that is optimistic approach and pessimistic approach. The optimistic approach basically involves versioning, and the pessimistic approach basically involves locking. Now let's move forward with the next question, that is, what are asset properties in database management system? Well, I would say this is also one of the most frequently asked questions in your interviews. So ACID, which stands for atomicity, consistency, isolation, and durability, is basically used to ensure that the data transactions are processed reliably in a database system. So if I have to define atomicity, consistency, isolation, and durability for you, then atomicity refers to those transactions which are completely successful or are failed. Here, each transaction refers to a single logical operation of the data. So even if one part of the transaction fails, then the entire transaction fails and the database state is left unchanged. Coming to consistency, consistency ensures that the data must meet all the validation rules. In simple words, you can say that your transaction never leaves the database without completing its state. Coming to the next term, that is isolation. The main goal of isolation is to make sure that concurrency control is met. And finally, coming to durability. Durability means that if a transaction has been committed, it will occur whatever may be the scenario, like any crash or failure or error and so on. So these are the four terms, guys: atomicity, consistency, isolation, and durability. Coming to the next question, that is, what is normalization and what are the different types of normalization? Well, normalization is basically a process of organizing data to avoid any duplication of data and redundancy. So there are mainly successive levels of normalization, which are known as normal forms, and each consecutive normal form depends on the previous one, right? Now, if I have to mention the different types of normalizations, then there are mainly four types of normalizations, that is 1NF, 2NF, 3NF, and BCNF. So to explain you all these types of normalization, let me take an example, right? So as you can see on my screen, I have a table which has basically salutation, full name, address, movies rented, and category. Now you see that Miss Alice Johnson has one particular address and has rented two movies of the same category. Coming to Mr. David Allen's address is basically divided into two different sections, that is 3rd Street, 45 and 7th Avenue, and then the movies rented are also divided into two sections, that is one section for sci-fi and one section for action. Now, obviously, we see data duplication because, David Allen is written twice. It can come in the same row. And also redundancy that, actually the category values are written twice. So to remove such kind of stuff, you can use normalization. Initially, any table starts with 1NF, right? So in 1NF, basically each table cell should have a single value, right? So basically all the records are made unique. If I have to divide this particular table into unique records, then what will happen is I'll divide as, a Miss Alice Johnson staying in this particular address will rent the movie Mission Impossible of category action. Similarly, you will have a different record which says Miss Alice Johnson staying in this particular address has rented movie Clash of Titans of category action, right? Coming to Mr. David Allen. Also, David Allen staying in 3rd Street 45 will initially rent Interstellar of sci-fi category, and similarly Mr. David Allen staying in 3rd Street 45 will again rent Edge of Tomorrow, and then the category will be sci-fi. Similarly comes to the 5th record. So we'll basically have 5 unique records as you can see on my screen. Now this is basically where your data is in 1NF, but still you see a lot of redundancy of data, right? So for that we next go to 2NF. Well, to make sure that the database is in second normalization form, the database should be initially in 1NF and should also have a single column primary key. So to make sure that the database is in 2NF, you have to make sure that database is in 1NF and should have single column primary key. So the previous table that I had chosen, I'll basically divide into 2 different tables. One will be table 1, which will basically have all the user details, and table 2 will basically have details of the movies rented. So after that, I'll introduce a column known as ID in both the tables, right? So in both the tables, what I'll do is I'll introduce ID for Miss Alice Johnson to be ID 1, David Allen staying in 3rd Street 45 to be ID 2, and David Allen staying in 7th Avenue will be ID 3. Now these particular users will rent specific movies, right? So basically I'll identify all those movies with respect to the IDs, right? So that's what I'm doing on my screen. So if you see, I basically have table 1, which basically has 3 IDs, and all these 3 IDs are used in the table 2, right? So in this way, you have basically the single column primary key. But yet, if you see over here also, there's a lot of redundancy of data as such, you see in the second table that, ID 1 is written twice, right? So to avoid that, what we do is we normalize the database into 3NF. To make sure that, the database is present in 3NF, you have to make sure that, the database is initially present in 2NF and must not have any transitive functional dependencies. So it basically should be in 2NF and should not have any transitive functional dependencies. To do that, what I've done is I've created one more table with the salutation ID and salutation so that, David Allen, who was written twice, is uniquely identified as one, as a single person, right? So in the 3rd table, I have salutation ID and salutation. And for Mr. I've put 1, Miss I've put 2, Mrs. I've put 3, and Doctor I've put 4. So according to that, I'll basically normalize this particular database. Now finally coming on to the 4th type of normalization, that is BCNF or Boyce Codd normal form. Now this is basically used in a scenario where your database is already in the 3rd normal form, but there are a few anomalies present, right? So when I say anomalies, what I mean by that is you can have more than one candidate key. Well, that is where BCNF comes into the role, where you divide your tables further and then there would be only one candidate key present. So guys, these are the various normal forms, that is 1NF, 2NF, 3NF, and BCNF. I hope that you've understood. Right, now let's move forward with the next question, that is what are the different types of keys in database? Well, there are mainly 7 different types of keys in database, that is candidate key, super key, primary key, unique key, alternate key, foreign key, and composite key. So to explain you the different types of keys, I'm going to consider the example that you can see on my screen. So starting with the candidate key first. Well, candidate key is basically a set of attributes which can uniquely identify a tuple. So basically each table can have more than one candidate key, and apart from this, out of all the candidate keys present, one key can be chosen as the primary key. So in the example that you can see on my screen, since customer ID and PAN number can uniquely identify every tuple, these 2 columns, or you can say that these 2 attributes would be considered as the candidate key. Coming to the next type of key, that is super key. Well, super key is a set of attributes which can uniquely identify every tuple. So a candidate key, a primary key, and a unique key is super key, but vice versa isn't true. Coming to the next type of key, that is primary key. Primary key is also a set of attributes which are used to uniquely identify every tuple. Now in the example that you can see on my screen, since customer ID and PAN number are candidate keys, any one of them can be chosen as the primary key. So I've chosen customer ID as the primary key over here, right? Coming to the next type of key, that is unique key. Well, unique key is similar to that of the primary key but allows null values in the column, right? So here the PAN number can be considered as the unique key. It might happen that few people do not have a PAN number. that particular attribute can be considered as the unique key. Coming to the next type of key, that is alternate key. Well, alternate keys are candidate keys which are not chosen as primary keys, right? So for example, if you see on my screen, I had two candidates, that was customer ID and PAN number. Out of the lot, I chose customer ID as the primary key. So the leftover one is the PAN number, which is chosen as the alternate key. Coming to the next one, that is foreign key. Well, you can understand foreign key as an attribute that can only take the values present as the values of some other attribute is basically the foreign key to attribute to which it refers. So in the example that you can see on my screen, customer ID from the customers table is referred to the customer ID from the customer payment table. So the customer ID from the customer's info table, or the customer's table, is basically the foreign key which refers to the primary key of the customer payment table, that is the customer ID. And finally, coming to the last type of key, that is the composite key. A composite key is a combination of two or more columns that identify each tuple uniquely. So in the example that you can see on my screen, the customer ID and the date of payment can be grouped together to uniquely identify every tuple in the table. So guys, these were the different types of keys. Now let's move forward with the next question, that is, what do you understand by correlated subqueries in database management systems? Well, a correlated subquery is also a sort of subquery reliant on any other query. So when subqueries are executed for each of the rows of the outer query, then they're termed as correlated subqueries. Now each subquery is basically executed a single time for every row of the outer query, right? So it's basically row by row processing. So you can also understand correlated subqueries as those queries which are used for row by row processing by the parent statement, right? Now here the parent statement can be select, update, or delete statements. Now let's move forward with the next question, that is, explain database partitioning and its importance. Now database partitioning is basically the process of dividing a logical database into independent units for betterment of availability, performance, and manageability. Now the importance of database partitioning is basically that it enables you to access large parts of specific partitioning. It enables us to use cheap and slower storage, which can be used to store data, and finally improves the query performance. Now let's move forward with the next question, that is, what do you understand by functional dependency and transitive dependency in database management systems? Talking about functional dependency first, a functional dependency is a constant which is used in describing the relationship among different attributes in a relation. For example, if you consider a relation A1 having attributes X and Y, the functional dependency among these two attributes will be X implies to Y, or you can understand that Y is functionally dependent on X. Coming to transitive dependency, a transitive dependency is a constraint which can only occur in relation of three or more attributes, right? So if you consider the same relation A1 having attributes X, Y, and Z, now X implies to Z is said to hold transitive dependency only if the functional dependencies X implies Y holds true, Y doesn't imply X holds true, and Y implies to Z holds true. So that was about functional dependency and transitive dependency, guys. Now let's move forward with the next question, that is, what is the difference between two-tier and three-tier architecture? Talking about the differences between two-tier and three-tier architecture, well, two-tier is similar to that of a client-server architecture, whereas the three-tier architecture contains an extra layer between the client and the server. So in the two-tier architecture, what happens is that clients directly communicate with the database at the server side. But in the three-tier architecture, clients communicate with an application or a GUI on the server side that makes the system more secure and accessible, right? So this application thereafter then communicates with the database system, right? Now let's move forward with the next question. That is, what are the differences between unique key and primary key? So in the previous questions, as I was telling you, what are unique keys and primary keys, I'm sure you already know the answer to this particular question. Well, unique keys can basically store null values, and primary keys cannot have a null value. Each table can have more than one unique key, whereas when it comes to primary key, each table can have only one primary key, right? So the main differences between unique key and primary key are, unique key can have a null value and primary key cannot have a null value. And each table can have more than one unique key, whereas each table can have only one primary key. That was about the differences, guys. Now let's move forward with the next question, that is, what is a checkpoint in database management system and when does it occur? Now, a checkpoint is a mechanism where all the previous logs are removed from the system and are permanently stored on the storage disk. So checkpoints are those points from where the transaction log record can be used to recover all the committed data up to the point of the crash. So that was about checkpoint, guys. Now let's move forward with the next question, that is, mention the differences between triggers and stored procedures. Now this is also one of the most popular questions asked in your DBMS interview questions. if I have to differentiate between triggers and stored procedures, then triggers are basically a special kind of stored procedure that is not directly called by a user, right? So in fact, a trigger is created and is programmed to fire when a specific event occurs. Coming to stored procedures are a group of SQL statements which can be reused again and again and again, right? So basically these statements are created and stored in the database. Now coming to the next difference, as I previously mentioned, a trigger cannot be called or executed directly by a user, right? So it's basically when the corresponding events occur, then triggers get created or are executed. But coming to stored procedures, we can execute a stored procedure by using the execute command or exec command whenever we want. The next difference is we cannot schedule a trigger, but whereas it comes to stored procedures, we can schedule a job to execute the stored procedure on a predefined time. Coming to the next one, that is that, we cannot directly call another trigger within a trigger, but when it comes to stored procedure, we can call a stored procedure from another stored procedure. The next difference between triggers and stored procedures is that, parameters cannot be passed as an input in triggers, whereas parameters can be passed as an input in stored procedures. Coming to the next difference, that is triggers cannot return values, whereas in stored procedures, triggers can return 0 or n values. And now finally coming to the last difference, that is, transactions are not allowed within a trigger. When it comes to stored procedures, you can use transactions within a stored procedures. So guys, these are the basic differences between triggers and stored procedures. Now let's move forward with the next question, that is, what are the differences between hash join, merge join, and nested loops? Now, hash join is basically used when you have to join large tables. Merge joins are used when projections of the joined tables are sorted on the joined columns. And nested loops are completely out of joins and basically consist of an outer loop and an inner loop, basically executing few tasks based on a condition. So guys, these are the main differences between hash join, merge join, and nested loops. Coming to the next question, that is, what do you understand by proactive, retroactive, and simultaneous update? Well, talking about proactive update first. These updates are applied to the database before it becomes effective in the real-world environment. Coming to retroactive updates, these updates are basically applied to a database after it becomes effective in the real-world environment. And coming to simultaneous update, these updates are applied to the database at the same instance of time as it becomes effective in the real-world environment, right? So guys, this is what the terms mean: the proactive update, retroactive update, and simultaneous update. The proactive updates are basically applied before it becomes effective in real world environment. The retroactive updates are updated on the databases after it becomes effective in the real world environment, and simultaneous updates are applied on the database at the same instance of time as it becomes effective in the real world environment, right? Now let's move forward with the next question, that is, what are indexes and what are the differences between clustered and non-clustered index? Now, if I have to define index for you, then indexes or index are basically data structures which are responsible for improving the speed of data retrieval operations on a specific table. So this data structure uses more storage to maintain extra copies of data by using additional writes. So indexes are mainly used for searching algorithms where you wish to retrieve data in a quick manner. Now coming to the differences between clustered and non-clustered index, a clustered index is comparatively faster than a non-clustered index. Now, the second difference is that, the clustered index basically alters the way records are stored in a database as it sorts out the rows by column which is said to be a clustered index, right? Coming to the non-clustered index, this does not alter the way the data is basically stored, but it creates a separate object within a table which points back to the original table rows after searching. And finally, coming to the third difference, that is, one table can have only one clustered index, but in non-clustered index scenario, one table can have many non-clustered indexes. So guys, these are the basic differences between clustered index and non-clustered index. Now let's move forward with the next question, that is, what do you understand by intension and extension? Intension, or most commonly known as database schema, basically defines the description of the database, right? So this is basically specified during the database design and mostly remains unchanged. Coming to extension, extension is the number of tuples available in the database at any instance of time, right? So this value keeps changing as and when tuples are created, updated, or deleted. So the data present in the database at a specific instance of time is basically known as the extension of the database, or most commonly known as a snapshot of the database. And the description of the database is basically known as intension, or most commonly known as database schema. Now let's move forward with the next question, that is, what do you understand by cursor and what are the different types of it? Now, a cursor is basically a database object which helps in manipulating data row by row and represents a result set. So the types of cursor available are implicit cursor and explicit cursor. Now, implicit cursor is basically a type of cursor which is declared automatically as soon as the execution of SQL takes place. So here the user is basically not indicated about the declaration of the cursor. Coming to explicit cursor, now this type of cursor is basically defined by the PL SQL as it handles a query in more than a single row, right? So that was about cursor and its different type, guys. Now let's move forward with the next question, that is explain the terms specialization and generalization. Now specialization is basically a process of defining a set of subclasses of the entity type, right? So here each subclass will contain all the attributes and relationships of the parent entity. Now apart from this, the subclasses may contain additional attributes and relationships specific to itself. Moving on to generalization. Generalization is a process of finding relations, common attributes for a particular set of entities, and finally defining a common superclass for them. So that is what specialization and generalization mean, guys. Now let's move forward with the next question, that is what do you understand by data independence? Well, when you say an application has data independence, what it implies is that, that the application is independent of the storage structure and the data access strategies of data, right? Now let's move forward with the next question, that is what are the different integrity rules present in database management systems? Well, there are mainly two different integrity rules present in DBMS, that is entity integrity and referential integrity. Talking about entity integrity first, this rule states that the value of the primary key can never be null. Right, so all the tuples in the column are identified as the primary key and should have a value. Coming to referential integrity, this rule states that either the value of the foreign key is null or it should be the primary key of any other relation, right? So guys, these are the basic different integrity rules present in database management system, that is entity integrity and referential integrity. Now let's move forward with the next question, that is what does fill factor concept mean with respect to indexes? Well, fill factor concept is basically used to mention the percentage of space left on an every leaf level page which is packed with data. So usually the default value is 100, right? So if you have to understand fill factor concept, guys, it's basically used to mention the percentage of space left on every leaf level page, right? So the default value is generally 100. Now let's move forward with the next question, that is what is index hunting and how does it help in improving query performance? Now, index hunting is basically a process of boosting a collection of indexes, right? Now, this is basically done as indexes improve the query performance and the speed at which they are processed. Now, it helps in improving query performance by suggesting the best queries using the query optimizer. Not only this, but index, query distribution, and the performance are used as metrics to check the effect. And finally, databases are tuned into small collection of problem queries, right? So that was about index hunting and how it improves the query performance, guys. Let's move forward with the next question, that is what are the differences between network and hierarchical database model? Well, network database model is basically where each parent node can have multiple children nodes and vice versa. And coming to hierarchical database model, it's basically a top-down structure where each parent node can have multiple child nodes, right? But a single child node can have only a single parent node. The main difference is that, in network model, each parent node can have multiple child nodes and vice versa. Whereas in hierarchical, it's basically a top-down structure. So basically, each parent can have many child nodes, but a child node can have only a single parent node. Coming to the next difference, that is the network database model supports one-to-one relationships, one-to-many, and many-to-many relationships. But coming to hierarchical database model, hierarchical only supports one-to-one relationship and one-to-many relationship. Now let's move forward with the next question, that is what is deadlock and how can it be resolved? Now deadlock is basically a situation which occurs when two transactions wait on a resource which is locked or other transaction holds. So deadlocks can be basically prevented by making all the transactions acquire all the locks at the same instance of time, right? So once the deadlock occurs, the only way to cure is to abort one of the transactions and remove the partially completed work. Now let's move forward with the final question for this particular section, that is what are the differences between exclusive lock and the shared lock? Now if I have to tell you the differences between exclusive lock and shared lock, exclusive lock is basically a lock on a data item when a transaction is about to perform the write operation. But when it comes to shared lock, a shared lock allows more than one transaction to read the data items, right? So that is the main difference, guys. Exclusive lock is basically a lock when a transaction is about to perform the write operation. And the shared lock is basically a type of lock which allows more than one transaction to read the data items. So guys, with this question, we come to an end to this particular section of this tutorial. Now let's move forward with the next section, that is SQL interview questions. So as I was telling you previously also, SQL is one of the foundations of database management system. So it's very important to know what are the top questions that could be asked related to SQL, right? So starting with the first question, that is, what are the differences between drop, truncate and delete commands? Now this is one of the most popular questions, or I would say one of the most frequently asked questions, as you know, all these three terms almost do the same thing. So the drop command is basically used to delete a database, table or a view. The truncate command is basically used to delete all rows from a table, and a delete command is basically used to delete a row from the table. So the drop is basically used to drop the complete table, database or a view. Truncate is to delete all the rows from the table, and the delete command is basically used to delete one row from the table. Now with the drop command, data cannot be rolled back. Even with the truncate command, the data cannot be rolled back, but when it comes to delete command, data can be definitely rolled back. Now the drop and the truncate commands are DDL commands, or data definition language commands, and the delete command is basically a DML command, that is the data manipulation language command. The drop command is basically slower than truncate. The truncate command is faster than drop and delete, and the delete command is slower than truncate. Right, so if I have to make it short, then the drop and the delete commands are basically slower than truncate. The drop command deletes the full structure of the table. The truncate command preserves the structure of the table, and the delete command also deletes the structure of the row from the table. So if I have to talk about drop, truncate and delete individually, guys, then the drop command is basically used to delete a database, table or a view. The data cannot be rolled back with the drop command, and it's a DDL command. It's comparatively slower than truncate and deletes the full structure of the table. Coming to truncate command is basically used to delete all the rows from the table, and data cannot be rolled back by using the truncate command. It's also a DDL command and is faster than the drop and the delete commands. Not only this, but it also preserves the structure of the table. Coming to the delete command, well, the delete command is basically used to delete a row in the table, and data can be rolled back using this particular command. It's a DML command and is slower than truncate, and basically deletes the structure of the row from the table. That were the differences between drop, truncate and delete command, guys. Now let's move forward with the next question, that is, what is SQL and where is it used? Now SQL, or most commonly known as structured query language, is the core of relational database, which is used for accessing and managing the databases. Now this language is basically used to manipulate and retrieve data from a structured data format in the form of tables, and holds relationships between those tables. So in layman terms, you can use SQL to communicate with the database, right? So that was about what is SQL, guys. Next, let's move forward with the next question, that is, what do you understand by subqueries in SQL? A subquery is basically a query inside another query, where a query is defined to retrieve data or information back from the database, right? So in a subquery, the outer query is called the main query, whereas the inner query is called the subquery. Now subqueries are always executed first, and the result of the subquery is passed on to the main query, which then executes the main query, that is the outer query. So it can be basically nested inside a select command, update command, or any other query. Not only this, but a subquery can also use any comparison operators like, greater than, less than, equal to, and so on. Now this was about subqueries in SQL, guys. Now let's move forward with the next question, that is, mention the differences between union and UnionAll. Now union basically combines the result of two or more select statements consisting of distinct value. But when it comes to UnionAll combines the result set of two or more select statements consisting of the duplicate values. So the syntax of union is union itself, that is only the word union, and the syntax of UnionAll is UnionAll itself, that is the words UnionAll. Now union also has lower performance than UnionAll, as duplicate rows need to be removed. And coming to UnionAll has a better performance than union, as duplicate rows need not have to be removed. So guys, these were the basic differences between union and UnionAll. Now let's move forward with the next question, that is, what do you understand by clause in SQL? Now clause in SQL is basically used to limit the result set by mentioning a condition to the query. So you can use a clause to filter the rows from the entire set of records, right? Now if I have to give an example, then example are basically where and having clause. Now let's move forward with the next question, that is, mention the differences between having and where clause. So having clause can be only used with the select statement, whereas the where clause can be used in a group by clause. This having statement is used with the group by function in a query, whereas the where is basically applied to each row before they are a part of the group by function in a query. Right? So guys, these are the main differences between having and where. Having is only used with a select statement, and where is used in a group by clause. Having can be used with the group by function in a query, whereas the where is applied to each row before they're a part of the group by function in a query. Apart from this, one more thing that I would like to tell you over here is that, whenever group by is not used, having behaves like the where clause, right? So guys, that was about having and where clause. Now let's move forward with the next question, that is, how can you perform pattern matching in SQL? Well, to perform pattern matching in SQL, you have to use the like operator, right? So with the like operator, you can basically use the percentage symbol and the underscore symbol. So the percentage symbol is basically used to match 0 or more characters, and the underscore symbol is to match exactly one character. So if you see the examples on my screen, I've written a query that, select star from customers where customer name like S percentage, right? So all the customers' names starting with S and whatever they have, like, let's say, my name is Sahiti, right? So I have 6 characters. Maybe there's Sonia. She has 5 characters, right? So all those names will be collected as sure. Coming to the next query, that is select star from customers where customer name like XYZ underscore. This basically matches only one character. So all those values which have XYZ in the starting and have only one character after that will be taken into account. Now let's move forward with the next question, that is mention few case manipulation functions in SQL. Now there are mainly 3 case manipulation functions in SQL, that is lower, upper and init cap. Now talking about lower function first, this function basically returns the string in lowercase, right? So it takes a string as an argument and returns it by converting into lowercase. Now the syntax is basically lower, and in brackets you have to mention in quotes the string, right? Now coming to upper function, this function is basically used to return the string in uppercase. So it takes a string as an argument and returns it by converting into uppercase, right? So the syntax is the same again. You have to mention upper, and in brackets you have to mention string. And coming to init cap is basically used to return the string with the first letter in uppercase and all the other letters in lowercase. So the syntax is again same. It's you just mention the keyword init cap, and in brackets you have to mention the string, right? Now these were few case manipulation functions in SQL, guys. Let's move forward with the next question, that is what are joins in SQL and what are the different types of joins? Well, a join clause is basically used to combine rows from 2 or more tables based on a related column between them. So it's basically used to merge 2 or more tables or retrieve data from there, right? So there are mainly 4 types of joins: the inner join, the right join, the left join, and the full join. So talking about inner join first. The inner join is basically used to return those records which have matching values in both the tables, right? Coming to right join, this is basically used to return all the records from the right table and also those records which satisfy a condition from the left table. And coming to the left join is similarly used to return all the records from the left table and also those records which satisfy a condition from the right table. And finally, coming to full join is basically used to return all those records which either have a matching value in the left table or the right table. So if you want a detailed understanding of the different types of joins in SQL, you can refer to my session on SQL joins. Now let's move forward with the final question for this particular section, that is what do you understand by a view, how to create a view, update a view, and drop a view. Now a view in SQL is basically a single table which is derived from the other tables, right? So a view contains of rows and columns similar to that of a real table and has fields from 1 or more tables. So to create a view, you basically have to use the syntax that you can see on my screen. So you have to mention create view, and then you have to mention view name, that is basically whatever you want to mention, and then use the as keyword. And after that you have to mention select and mention all the columns that you wish to choose from table names where condition, right? If you want to mention the condition, you mention the condition. Now to update a view, you have to use the syntax that, create view or replace view, and then mention the view name as, and then again mention select and mention all the columns from where you want to select from table name where condition, right? And similarly, coming to drop view, well, the syntax to drop view is very simple. You just have to use the keyword drop view and then mention the view name. So guys, that was about view and how to create, drop, and update a view. Now let's move forward with the next section, that is SQL query interview questions. Now obviously, since SQL is a language through which you can manipulate data, it's very important for all of us to understand how to write queries to retrieve the data, right? So for that, let's look at the top questions asked in this particular section. But before that, if you want a detailed understanding on the top SQL questions asked in interviews, you can refer to my session on SQL interview questions. Alright, starting with the first question, write a query to create a duplicate table with and without data present. Now consider you have a table named customers having details like customer ID, customer name, and so on. Now, if you have to create a duplicate table, let's say duplicate customer with the data present in it, you have to mention the query as you can see on my screen. That is create table and mention the table name, that is duplicate customer, as select star from customers, right? This will basically create a duplicate table of the real table with all the data present. Similarly, if you want to create a duplicate table without the data present, you have to mention the query again that you can see on my screen. That is create table duplicate customer as select star from customers where 1 equal to 2. So basically the data will not be present in the duplicate table in such a scenario by using this query. Now let's move forward with the next question, that is mention a query to calculate the even and the odd records from a table. Now to write a query to calculate the even and the odd records from a table, you can write two different queries by using the mod functions, right? So if you want to retrieve the even records from the table first, you have to basically write the query that you can see on my screen. So I am again considering the customers table, right? So I'll mention select customer ID from, and the subquery I'll mention select row number, comma customer ID from customers, where mod, and then in the brackets I'll mention row number, comma 2 equal to 0, right? So I'm sure all of us know how mod function works, right? So whenever we divide, let's say 5 divided by 2, we get a remainder 1. That means that, it's an odd number. But if we divide 6 divided by 2 and then we get a remainder 0, that means it's an even function, right? So that's the same logic that works over here also. Now, similarly, if you want to retrieve the odd records from a table, you mention select customer ID from, and in the subquery, you mention select row number, comma customer ID from customers, where mod row number, comma 2 equal to 1. So that's how, guys, you can retrieve the even records and the odd records. So now let's move forward with the next question, that is write a query to remove duplicate rows from a table. Now to remove duplicate rows from a table, you have to initially set the duplicate rows from the table without using the distinct keyword, right? So to select the duplicate rows from the table, you can write a query as you can see on my screen. That is select customer number from customers where row ID, and in the nested query you mention select max row ID from customer C where customer equal to C dot customer number. Right? And now once all the duplicate records are selected, to delete the duplicate records from the customer table, you have to mention the query that you can see on my screen. That is delete from customers where row ID, and in subquery you mention select max row ID from customer C where customer number equal to C dot customer number. So that's how, guys, you can remove duplicate rows from a table. Now let's move forward with the next question, that is mention a query to add email validation to your database. Even I would say to answer to any particular query is not specifically unique, as you may have various approaches to solve a problem, right? So to add email validation to your database, I would say that you can use the query that you can see on my screen, that is select email from customers where not regular expression underscore like, and in the brackets you mention email, comma, and then you'll mention all the characters that it has to match, right? So I'll mention A to Z characters, and then 0 to 9 characters, dot, underscore, percentage plus, year, plus, minus, and so on, right? So this is one way you can add email validation to your database, but this is not the only way. Now coming to the last question for this particular session, that is write a query to retrieve the last day of the next month in Oracle. So the query to retrieve the last day of the next month in Oracle, you can write a query as you can see on my screen. Select last day, and in brackets you mention add month, and in inner brackets again you mention system date, comma 1 from dual, right? So guys, these were a few queries that you can practice for your DBMS interview questions. So apart from that, guys, with this we come to an end to this particular session. I hope you've understood all the questions, and if you yourself have attended any interviews related to DBMS and SQL, please comment your question in the comment section and we'll reply to you as soon as possible. So this will be all from our side today. I hope this set of questions will help you crack your interviews. So I hope you found this session informative. Thank you and have a great day.